Did you understand question number 13? See here, this is almost the differentiation of this. How did I know? Because x3 differentiation of it is x2. And the x differentiation of it is a number. So this is a function e to the power of function, and here is almost f dash. It's not exactly f dash, but it is almost f dash. So how can I do that? I will say let u equal f x to the power of 3 plus 6x. Now if I differentiate du over dx, that will give me 3x squared plus 6, right? How can I make dx the subject? Dx equal du over 3x squared plus 6. Do you understand? Therefore, I equal, what is I? Integration. It will be integration of e. And instead of writing this, I will write u. Right? It will be e to the power of u. Write x squared plus 2. dx is du over, see, 3x squared plus 6. I can take 3 as a common. So it's going to be 3 out, then x squared plus 2, right? Why did I do that? So I can cancel this with this. What still I have? I still have only this 3, which is down. I will take it out. The integration, eu du. This is really easy. It is really easy. It's going to be 1 over 3. What is the integration of e? It is e itself over 1, which is the differentiation of u. You understand? Now substitute again. Substitute. So your answers, to make your answer be in terms of x. So this will be 1 over 3 e. What is u? It is x3 plus 6x plus c. Was it understood? Was it clear?
Yes.
Yes.
Yeah.
Ahmed, I can't hear you.
داش اصلا.
How did I know? How did I know that this is if and this is if dash?
كيف عرفت؟ كيف؟
Okay, Ahmed, when it is x to the power of 3, what is the differentiation of it? It has to be number 3x squared, right?
Yeah.
So x squared is going to be part of x f dash.
Okay.
Okay. While 6x, what is the differentiation of 6x? It is 6. So it is a number like 2. When it is a number, that means it is a differentiation for x. When you have x to the power of 5 plus x to the power of, let's just say 2. A differentiation of this can be written in x to the power of 4 plus x to the power of 1. If this exists, that means it is f dash of this f.
يعني the same form.
Yeah.
Yeah, I get it.
You got it?
Yes.
Okay, I will show you more in the next page. See, Ahmed, this is x squared, right? And this is x. This is length. This is length. It's 1 over x. So you can say that this is if, and this is almost if dash. It's not exactly if dash, but it is almost if dash.
Same form as if dash.
You'll see what will I do. So you will say let u equal x squared plus ln x squared. Okay? Okay. What is du over dx? It is 2x, right? Differentiate this. It will be plus. What is the differentiation of ln? The function itself. And up we will have 2x, which is the differentiation of x squared. Right? Is that clear? Simplify it. Simplify this. It will be 2 bracket x plus, it is x plus 1 over x. Why 1 over x? Because, see here, you can cancel this x with this squared. And 2 is a common. You understood? What did I do?
Yes.
Good. Good. So, now integration is going to be I forgot just to make dx the subject. What will it be? It will be du over 2 x plus 1 over x, right? Now, I equal integration. Leave that as it is, x plus 1 over x. Don't touch it. E, and instead of writing x squared plus ln x2, write it u. Dx is this, du over 2 x plus 1 over x. What will happen now? Cancelled, right? As you can see, I'm trying to make my integration easy. Instead of it is being hard, right? So it is have integration of eu du. Nothing is easier than this. This is the easiest thing in the whole world. So it's have eu plus c. Substitute u again. It is have e. What is u? What is u? Just substitute it to be in terms of x. It is x squared plus ln x squared plus c. You understood?
Yes. Yes.
Okay. Before we finish, I need you to take a screenshot of the previous page. Let me just have. I did my own screenshot so I can share it to our group. Okay. Have a screenshot for this solution. So because I need to erase it and show you another way, little bit different. It will be almost the same, but it's not exactly the same. I will show you a new thing. I will show you a new thing. Where will I do it? I will do it next. I will do it here. So you can compare between both ways. See, I will have the same substitution. I will say u equal x squared plus ln x squared. Okay? See what will I do? I will do it this way. Du equal 2x plus 2x over x squared dx. Are you with me?
Yeah.
Yes. Equal du equal 2 will be out, still have x plus this x will be cancelled with the squared, so it's 1 over x dx. Okay, get back to our integration. As you can see, it is, I can write it this way. It is e x squared plus, let me just change the color so it can be clear for you. I need it to be so clear for you, so you can get what I'm trying to tell you. My integration can be written like this. I will put e at the beginning, ln x squared, okay? Then x plus 1 over x dx. Are you with me? It is the
Yes.
same as my question, right? See my question here? This is exactly as it, but I put something at the beginning, and the beginning I let it to be in the end. You understand?
Yes.
Okay, now, if I add 2 here and 1 over 2 here, can I do that? Yes, I can. It will be 1 over 2 integration e. Now, substitute. X squared plus ln x squared is 0, right? And this all is du. Isn't that the same? See, I
Yeah.
got the same thing. I got the same thing. Equal have eu equal have e. Write u in its terms, x squared plus ln x squared plus c. What do you think? Is there a big difference between the method 1 and method 2? You saw the difference between this method, the first one, and the second one. My question, Rana, is which one you think the other students, the average students, will understand easily?
I think that second
The
method
first.
is more of a
I think the first will be easier. Wouldn't you say that? I need your point of view.
That's what I think.
Because you are getting what you are trying to do. Second way, yes. The second way is more organized and more beautiful. It's really nice, but the question is, will the average students understand it? The
I
question.
think the first because it's hard work.
That's why I'm always doing this in my classes, not this. But for the best students, for the good students like you, excellent students actually, like you, I use this. Okay, do screenshot. Do screenshot. I will clean the method in the left, in the right, I'm sorry. As you can see, we have ln and we have 1 over x, which is the differentiation of ln, right? So I will say let u equal ln x. So du equal 1 over x dx. How easy is this? This is really easy. So integration is I equal cosine u And as you can see, dx and 1 over x is du. Right? Is it
Yeah.
clear? For you?
Yes.
Equal. What is the integration of cosine? It is sine. U. We finished. Substitute u again. Sine. What is u? It is ln x plus c. Okay? Clear?
Yes.
Let's just move to the next. Okay. Aha. This is the third type. This is the third type. Okay, where is the first? Where is the second? You say this is the third type. Question number 17 is the type 3. Okay, teacher, where is type 1 and type 2? Okay, I will show you. Okay. Type 1 is the questions from number 1 to from number 1 to 12. This is the type 1. These are all can be done by using substitution also. But because it has a rule, which is this or this, we don't have to use substitution anymore. This is type 1. For example, if we did the first question, u equal x to the power of 3 plus 2x, I will get the same answer. You want me to try and show you?
Yes.
I'm asking. Okay, so I will need to clean. And khalas, we did our screenshot. I will leave the first question. I will leave the answer so we can compare our new answer. If I say, let u equals x to the power of 3 plus 2x. Okay, so du equal 3x squared plus 2 dx. Right? So the integration is going to be integration of, see this all is du, صح? Is du over. What is this? It is u. Du over u, it is ln u. Right? Now substitute u again, it is ln, what is u? This is it. Is x to the power of 3 plus 2x plus c. Isn't this similar to this?
Yeah.
It is the same. But because it is recurring rule, it always happens like that. Khalas, we have it as a general rule. We don't use substitution to do it. Because it's a function and it's differentiation. That was the type 1. That was the type 1. You can have a screenshot for this. Do screenshot because I will move. While type 2, it's not function and its differentiation. It is function, sine f, and if dash is next to it, there is sign between them, or e, like in the second question. This is type 2. We need substitution. We have to do substitution for that. We have question 13 and question 14. Also question 15 and 16. They are all type 2. While type 3, See here, this is x, make it big. See this, it is x and bracket. Question, is this if dash, if this? No, it's not. No, it's not. This is x and this is x. This is not the differentiation of this. If this is x squared and this is x, that's it. We will use, it will be the first type, the first type. You understand?
Yes.
But now I will have to use substitution because opening this is long story. So x plus 1 to the power of 3 is really long. See what will I do? I will do the following. I will say let u equal 2x plus 1. Okay, you are all with me, right?
Yes.
How can I make x the subject? I will take 1 to be 2x equal u minus 1, right? Divide here by 2, divide here by 2. So x equal u minus 1 all over 2. You got that? Okay.
Yeah.
Du over dx equal 2. Right? It is 2. Now make dx the subject. Dx equal du over 2. Substitute, therefore, I, which is integration, equal. Now substitute every x in terms of u. This x will be u minus 1 over 2. U minus 1 all over 2. Okay? Then 2x plus 1, it is u. So it's going to be u to the power of 3. Are you with me?
Yes.
And dx is going to be du over 2. Because of this. Right? So I will take this 2 and this 2 outside the integration. So it's going to be 1 over 4 integration of u3 bracket u minus 1 du. Open. It will be 1 over 4 integration. Until now, I didn't integrate yet. I'm still trying to make it standard case. So it's u4 minus u3, right? Du equal 1 over 4. What is the integration of u4? It is u5 over 5 minus u4 over 4. Okay? Equal. Now substitute u again. Is 1 over 4, big bracket, 1 over 5. Okay? What is u? What is u? It is here. It's 2x plus 1. Okay? To the power of 5 minus 1 over 4. 2x plus 1 all to the power of 4 plus c. Of course, we can simplify it more than that. We can simplify it more than that. It equals 1 over 4. Okay. 2x plus 1 all to the power of 4 bracket 1 over 5 bracket 2x plus 1 minus 1 over 4 plus c. You understand how did I do that?
Yes.
No.
Yeah.
آخر شيء.
Okay, Abrar, if you can see, this is repeated. It's recurring here and here. This is 2x plus 1 to the power of 5 and 2x plus 1 to the power of 4. You take this as a common. You take it out. What still I have? I will have 1 over 5 and 2x plus 1 because it's 5, not 4. And here, خلاص, I took it all out. Abrar, see, I will do it here. I will do it here. See, this is U5 and U4. U5 and U4. What can I take as a common? 1 over 4 will stay as it is. بعدين U4 as a common bracket. U over 5 minus 1 over 4, right? Did you understand? Abrar, you still with us?
I think he left.
What is the appropriate substitution here? What is the proper one? What do you say? Let U equal. Now make the x subject. We will take the 2 next to u, so 3x equal u plus 2, divide both sides by 3. So this is x if you want to substitute x. Okay? du over dx equals 3. Make dx the subject. Dx equals du. Sorry.
Sir, I have a
du.
question.
Yes, ask.
Can we just choose whatever to be u, or is it like something specific?
Not everything would work. Sometimes you choose a substitution and you try to rewrite your question, and after a while, you will discover that you made it more complicated than it was. You understand? If you got, if that happened to you, just clean use substitution and try another substitution. Okay, how can I know the right substitution from the beginning? This can come if you did many questions. What we call it, the common sense. If you had the common sense, if it is, if this topic is a second nature for you, you do it as fast as you deal with your phone. خلاص. By doing many questions. How can you get that level? By doing many exercises, many questions. Solve and solve, practice and practice and practice. That way you will be able to know the right substitution directly. You understand?
Yeah.
Good. Abrar, are you with us now? Take